Some galaxies may never turn on. That sounds wrong. A galaxy, in our minds, is supposed to be made of stars, spiral arms, glowing dust, clusters of light, a bright island floating in the darkness. For more than a century, that is how we have imagined the universe. We looked up, saw light, mapped the light, named the light, and called that the cosmos. But what if that was only the visible part of the story? What if some galaxies are there but never learned how to shine? In 2026, astronomers using the Hubble Space Telescope confirmed something strange near the spiral galaxy Messier 94, a compact cloud of hydrogen gas. No obvious stars, no glowing galaxy, no beautiful spiral arms, just gas, and something massive enough to hold it together. The object is nicknamed Cloud 9, and it may be the first confirmed example of a kind of object scientists have expected for years but almost never see. A starless dark matter cloud, a failed galaxy. The phrase sounds almost poetic. A galaxy that had the ingredients but not the fire. Tonight, we explore Cloud 9 and why a galaxy with no stars may tell us more about the universe than some galaxies filled with them. When I was younger, I thought space was mostly about what you could see. The moon, Jupiter, Saturn, the brighter stars. Later, when I started learning astronomy more seriously, I realized that almost everything important was hiding behind the obvious. The glow was only the invitation. The real universe was underneath it. Gravity, gas, dark matter, invisible structure, the things that shape the light, even when they do not produce any light themselves. Cloud 9 is a perfect example of that. At first, it was not discovered because it looked beautiful in a telescope. It did not look like much at all. It was first noticed through radio observations of neutral hydrogen. Hydrogen gas can emit a specific radio signal at a wavelength of 21 centimeters. That signal is one of astronomy's quietest fingerprints. It lets us find gas even when there are no stars to illuminate it. Radio telescopes saw the hydrogen, but hydrogen alone was not the full mystery. The question was simple. Was this just a gas cloud, or was it something darker? Something gravitationally bound, something sitting inside a halo of dark matter. Something that was almost a galaxy. To answer that, Hubble looked for stars. That sounds straightforward. Point a powerful telescope at the cloud. Look deeply. If there are stars, you should see them. But Hubble found no clear stellar population, no normal dwarf galaxy hiding in the gas, no tiny swarm of ancient stars bright enough to explain the object, just a starless cloud. And that is where the problem begins. Because gas clouds do not usually stay together on their own. Gas spreads, it drifts, it gets stripped away. If Cloud 9 has survived, compact and coherent, near a galaxy like M94, then something may be holding it. The best candidate is dark matter, not a little dark matter. A lot of it. Enough to make Cloud 9 behave less like a random cloud and more like a dark halo that failed to become a proper galaxy. This is where the old picture of galaxies starts to crack. We often think of galaxies as collections of stars. But in modern cosmology, stars are not the foundation. Dark matter is. A galaxy begins with an invisible gravitational skeleton, a dark matter halo. Gas falls into that halo. If the gas cools enough, it collapses. If it collapses enough, stars ignite. Then the invisible skeleton becomes visible. A galaxy turns on, but what if the gas never crosses that threshold? What if the halo forms, but the stars never do? Then you get something like Cloud 9, a structure with mass, a structure with gas, a structure with gravity, but no light. A galaxy before the first spark, or after the spark failed. That should make us pause. Because if galaxies are only the ones that turned on, then maybe our maps of the universe are biased. We have been mapping the fireworks, not the scaffolding. This is not just a strange object. It touches one of the biggest ideas in cosmology. The standard model of the universe, known as lambda cold dark matter, predicts that dark matter should form many small halos. Some become galaxies. Some become dwarf galaxies. Some may remain almost invisible, too small to hold enough gas, too weak to cool efficiently, too affected by radiation from the early universe. They exist in the math, but finding them in reality is hard. Because if something has no stars, it does not announce itself. It does not shine. It does not appear in a pretty Hubble image. It waits in radio data, in motion, in gravity, in absence. That may be the most interesting part of Cloud 9. It is a discovery built around something that is missing. No stars, no starlight, no normal galaxy. In astronomy, absence can be evidence. That is not easy for the human mind. We like positive proof, a bright object, a clear signal, a photograph. But sometimes, the universe speaks through silence. The fact that Hubble did not find stars is part of what makes Cloud 9 important. It suggests this object may be a reionization-limited hydrogen-1 cloud. ARELHIC. The name is ugly. The idea is beautiful. In the early universe, after the first stars and galaxies formed, ultraviolet radiation filled space. That radiation heated and ionized gas. For small dark matter halos, this was a problem. They may have had enough gravity to capture some hydrogen, but not enough to cool it into stars. The gas remained warm, stable, unable to collapse. The halo survived. The galaxy never lit. Cloud, the 9th of May, be one of those survivors. A fossil of galaxy formation that never became a galaxy in the usual sense. Not dead, not alive, not empty, not luminous. A cosmic almost. That word matters. Almost. Almost a galaxy. Almost visible. Almost part of the universe we normally recognize, but stuck in between. This is why I find Cloud 9 more haunting than many bright galaxies. A bright galaxy tells you what succeeded. Cloud 9 tells you what failed, and failure is often more revealing. When something works, it can hide the process. When something fails, the machinery is exposed. Cloud 9 shows us the step before starlight, the dark matter halo, the gas, the missing ignition, the boundary between invisible structure and visible galaxy. It is like finding a match that never caught fire, and suddenly learning something about flame. Of course, scientists have to be careful. Cloud 9 is not a final answer to every dark matter mystery. It is one object, one candidate, one remarkable example. There may still be details to test. Could it contain stars too faint to detect? Could its gas be shaped by interactions with nearby galaxies? Could the mass estimates change with better observations? Yes. Science does not end with a nickname, it begins with measurement. But even the cautious version is exciting, because if Cloud 9 is real as a starless dark matter halo, it means the universe contains structures that our eyes were never built to notice. And that changes the emotional meaning of the night sky. The darkness between galaxies may not be empty. It may be filled with failed attempts, dark halos, gas clouds, invisible seeds, structures that never became bright enough to join our maps. For most of history, humans believed the universe was made of what shined. Then we learned that stars were not enough. Galaxies had missing mass. Clusters had too much gravity. Light bent around things we could not see. The cosmic microwave background showed a universe shaped by invisible matter. And slowly, we accepted something deeply uncomfortable. Most matter does not glow. Cloud 9 makes that discomfort local, specific, almost tangible. Here is a place. A cloud near a galaxy. A thing with gas and gravity. But no stars. It is not abstract dark matter in a textbook. It is an object, or almost an object, a dark structure refusing to become visible. That is what makes it powerful. Because it reminds us that astronomy is not just the study of light. It is the study of everything light fails to show. When I think about Cloud 9, I imagine the early universe as a field of possibilities. Some regions gathered enough gas and became galaxies. Some became small dwarfs. Some were torn apart. Some merged into larger structures. And some, maybe many, stalled. They had dark matter, they had hydrogen, they had gravity, but they never crossed the line into starlight. No first sunrise, no stellar nursery, no supernovae, no planets. No chemistry around young stars, just a dark halo holding gas in silence for billions of years. That is not an empty universe. That is a universe full of unfinished stories. And maybe that is the deeper lesson. The cosmos is not only built from what becomes spectacular, it is also built from what almost happens. Almost stars, almost galaxies, almost worlds, almost futures. Cloud the 9th of May be one of those almosts. A small, dark reminder that creation is not guaranteed. Gravity can gather the ingredients, time can pass, the universe can wait. And still, nothing lights up. That thought stays with me. Because we usually talk about the universe as if complexity is inevitable. Gas becomes stars, stars become galaxies, galaxies become planets, planets become life, life becomes intelligence. But Cloud 9 whispers a different message. Sometimes the chain breaks early, sometimes the universe builds the stage, and the first actor never arrives. So here is the question I want to leave with you. What is more unsettling? A universe that is mostly empty, or a universe filled with invisible structures that never learned how to shine? Some people may see Cloud 9 as a beautiful confirmation of our cosmological models. Others may see it as a warning that our maps of the universe are still biased toward light. I want to know which side you are on, because maybe the real universe is not hidden beyond the stars. Maybe it is hidden between them. And maybe the most important galaxies are not the ones blazing across our telescopes, but the ones that never turned on.